morning, Year 6, and welcome to our first maths lesson of this half term. So we're going to be rewinding all of our learning. So every week we're going to have a different topic, and this week's topic is fractions. So my plan for us is, today we're going to rewind to simplifying fractions and converting between mixed numbers and improper fractions and vice versa. Tomorrow we're going to do comparing fractions using common denominators. Wednesday we're going to do adding and subtracting fractions. Thursday, multiplying and dividing fractions, and then on Friday we're going to do fractions of amounts, and then we're going to consolidate all of our learning by using our Power Maths books and doing a problem lesson. So all problem solving on fractions on Friday.
So first things first, I want you to think about what is a fraction. So a fraction is part of a whole. You've got the denominator, which tells you how many equal parts your object is cut into, and then you have two of those equal parts. So this is 2 out of 4, 2 quarters. If I said to you that you could simplify this fraction, what would I mean? What would I mean by simplifying a fraction? Well, it means to make something simpler, to make something easier to work with. So when we talk about simplifying fractions, we talk about finding an equivalent fraction that is easier to work with. And the way we do this is we think about what common factors do these two numbers have? What is a number that I can divide 2 and 4 by to make this fraction here easier for me to work with? Now, when I think about my factors, I think about factor bugs. So 2 goes in the middle. So I always start with, can I divide it by 1? Of course I can. What do I times 1 by to get to 2? I times it by 2. So these are the two factors of 2. Because it's only got two factors, this tells me it's also a prime number because it's only divisible by 1 and itself. These are the only two factors of 2. If I think about what are the factors of 4, well, I always start with 1 and itself. So I know that 1 and 4 are factors because I multiply them together to get 4. What else can I multiply by to get to 4? Well, I've done 1, so now I look at 2. So it would be 2 times 2. Can it be divided by 3? Is 3 a factor? No, so I stop there. This, incidentally, because it's got 3 factors, or it's got an odd number of factors, is actually a square number because 2 times 2 would be 4. So if I look at both of these, I can look at the common factors that I can divide both these numbers by. Now, you're always going to have 1 as a common factor, but there's no point dividing this fraction by 1 because it would stay the same. So the other common factor is 2. I can divide both of these numbers by 2 because 2 is a common factor. So back to my fraction then, and of course normally we'll do that in our heads. Okay, we don't need to write out all the factors, we can just do it mentally. So 2 divided by 2 would be 1, 4 divided by 4 would be 2. This then tells me that 2 quarters is the same as 1/2. Now, to prove this, I've drawn a diagram down here. So this one here shows me 2 quarters. My whole is split into 4 equal parts, and I have 2 of those equal parts. And I can see by the way I've drawn it that this is the same as having a whole split into 2 equal parts and having 1 of those equal parts. So, to recap, when we're trying to simplify a fraction to make it easier to work with, we are looking for a common factor of the numerator and the denominator. We can then divide both those numbers by that factor, and we get an easier, simpler fraction. So, I'm looking at 3/9. What's a common factor of 3 and 9? Well, I'm going to do this in my head this time rather than drawing out a factor bug, but I know that 1's a factor of both of them, but there's no point dividing by 1 because the number would stay the same. Can I divide them both by 2? Is 2 a factor? No, because both these numbers are odd, and multiples of 2, are always even. Can I divide them both by 3? Is 3 a factor of both of these numbers? Yes, I can do 3 divided by 3, which would be 1. I could do 9 divided by 3, which would be 3. These two fractions are equivalent. This is a simpler version of this fraction here. Now, can I simplify this fraction any further? Well, no, I can't, because both these numbers are prime numbers, which means they only have the factors of 1 and themselves. So the only thing I could divide them both by is 1, which wouldn't change my fraction. My next one is 12/16. Now I'm looking at both these numbers and I can see straight away that they are even. So you've got two options here. You can either divide them both by 2 and then see if you can simplify them any further, or you can look for
other factors, maybe a higher common factor, to see if you could divide them by something else first. So I'm going to divide by 2 first of all, and I'm going to prove my method. So if I divide them both by 2, 12 divided by 2 is 6. 16 divided by 2 is 8. Right, I'm going to look at this fraction. Can I simplify it further? Yes, because both these numbers are even, so I can divide them both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4, 3/4. Can I simplify it any further? No, I can't, because 3 has only got the factors of 1 and 3, 1 in itself. You can't divide 4 by 3, so you stop there. It cannot be any simpler. So what I did was I divided by 2, and then I divided by 2 again. However, hopefully you can see a relationship. What have you divided 12 by to get to 3? What have you divided 16 by to get to 4? If you divide by 2 again is the same thing as dividing by 4. If you'd looked at these numbers and seen actually they had another common factor of them was 4, you could have divided by 4 straight away rather than doing it in 2 steps. But it's completely up to you. Okay, I now want you to have a go at the first part of this question. So it's asking you to sort the fractions on the right hand side into the table. So which ones simplify to a half, which ones simplify to a third, and which ones simplify to a quarter. And when you've done that, there's a few questions underneath for you to have a go at. Have a go, pause the video, and then we'll go through the answers in a moment. Right, let's go through some answers then. So 5/15. A common factor of these would be 5. If I divide them both by 5, it would be the equivalent to 1/3. 2/4, I can divide them both by 2, so this is equivalent to 1/2. 4/16, I can divide them both by 4, so this would be equivalent to 1/4. 8/16, I could divide them both by 4, so it would be 2/4. Ooh, now I'm looking at that one. I think I can divide it by something else. I can divide them both by 2, which would be equivalent to 1/2, or I could have divided them by 8 straight away to get to 1/2. 2/8, I can divide them both by 2, which would be equivalent to 1/4. 3/9, I could divide them both by 3 to be equivalent to 1/3. 6/12, I could divide them both by 6, which would be 1/2. 5/10, I can divide them both by 5, which would be equivalent to 1/2. Now, then the questions underneath asked if you could see any patterns or any relationships between the numerators and the denominators and which column they'd been put into. So first of all, I want us to have a look at the ones that are equivalent to 1/2. So 2 and 4, not that one, 8 and 16, 6 and 12, 5 and 10. What do you notice about the numerators and the denominators and the fact they're equal to 1/2? Well, hopefully what you can see is 1/2 of 4 is 2, 1/2 of 16 is 8, and 1/2 of 12 is 6, and 1/2 of 10 is 5. So all of these fractions are equivalent to 1/2 because the numerator is 1/2 of the denominator. Now, if we have a look at the ones that are equivalent to 1/4. So we've got 4/16 and 2/8. Again, looking at these numbers, hopefully you can see the same pattern. 2 is 1/4 of 8. 8 divided by 4 is 2. 4 is 1/4 of 16. 16 divided by 4 is 4. Lastly, and hopefully you are starting to spot the pattern already, if you look at the ones that are equivalent to 1/3, so 3/9 and 5/15, hopefully you can see that the numerator is 1/3 of the denominator. And again here, 3 is 1/3 of 9. 3 times 3 is 9. So that hopefully can help you to see sometimes you don't need to simplify them by working out the factor. Sometimes you can look in your head and think, right, if I know that 5 is 1/2 of 10, I know that that's equivalent to 1/2. So when a fraction is equivalent to 1/2, the numerator is 1/2 the denominator. When a fraction is equivalent to 1/3, the numerator is 1/3 of the denominator. And when the fraction is equivalent to 1/4, the numerator is 1/4 of the denominator. Okay, we're now going to move on to mixed numbers and improper fractions. This is a mixed number because it's got a number and a fraction. An improper fraction is one where the numerator is larger than the denominator. Okay, and we convert between these to help us work out problems. So,
if I've got 2 wholes and 1 quarter, I need to think about how many quarters would make 1 whole. If I had the whole cake and it was cut into 4 pieces, if I had the whole thing, I would have 4 of those pieces. Right, what about if I had 2 wholes then and it's still cut into quarters? Hopefully you'd be able to tell me that I would have 8 quarters. So this 2 wholes here is the same as 8 quarters and another quarter. This is equivalent to 9 quarters. This is an improper fraction and this is a mixed number. So we can draw this out, but I want us to try to use our times table knowledge. If we know that 1 whole is the same as 3/3, 2 wholes would be 6/3. So 3 times 3, 3 wholes would be 9/3. Add another one. So this is equivalent to 10/3. What about if I had 5 wholes then? If 3 wholes was the same as 9/3, think about what 4 wholes would be. So what's 5 wholes then? Well, 5 times 3 is 15. So 5 wholes will be 15/3. Add 2 more. 17/3. Now we're going to go from improper fractions to mixed numbers, and this is just doing the same process we've just done but backwards. So this time we need to think about how many wholes can we make out of 18 quarters. Well, I know that 1 whole is the same as 4 quarters. So if I've got 18 quarters, could I make 1 whole? Yes, I could. Right, if I know that 1 whole is 4 quarters, 2 wholes is 8 quarters. If I had 18 quarters, could I make 2 wholes? Yes, I could. 3 wholes then is going to be 12 quarters. Could I make 12 quarters? Yes, I could. So I could make 3 wholes. 4 wholes is going to be the same as 16 quarters. Have I got enough to make 4 wholes? Yes, I have. For 5 wholes, I'd need 4 times 5, which is 20 quarters. Could I make 5 wholes? Well, no, I couldn't because I've only got 18 quarters. So I'd have enough to make 4 wholes, which is 16 quarters. But I had 18, so I've got 16, 17, 18. So I've got 4 wholes and 2 quarters left over, which I could also simplify to 4.5. So if I look at this one, and again, I'm going to try and do this with my times tables this time, and without writing it all out or drawing it. If I know that 1 whole is 3/3, 2 wholes is 6/3, 3 wholes is 9/3, 4 wholes would be 12/3, and there would be nothing left over. 12/3 is equivalent to 4 wholes. If I had 12/5, how many wholes could I make? Well, I could make 1 whole, so that'd be 5/5. I could make 2 wholes, because that would be 10/5. But I've got 12/5, so there'd be 10, 11, 12, and 2/5 left over. Just to finish off our learning today, we're going to look at a very common misconception. So, Tony thinks that 4 wholes and 12/16 is equivalent to 1 whole and 3 quarters. Now, to pause the video, and I want you to think, what has Tony done to get from 12/16 to 3 quarters? And what's he done to get from 4 wholes to 1 whole? And where has he gone wrong? So, hopefully you can see that Tony has tried to simplify this fraction. He's simplified 12/16. He knows that a common factor is 4. 12 divided by 4 is 3. 16 divided by 4 is 4. So he's divided the fraction by 4. He's made the fraction simpler. However, he's also divided the wholes by 4. And hopefully you know that that's not how it works. Okay, we can't simplify the wholes because they are the whole thing. The only thing we can simplify is the fractions because we're making the fraction easier to work with. So what Tony should have done is he should have simplified the 12/16 to 3 quarters, and then you've got to have your 4 wholes. So the answer would have been 4 wholes and 3 quarters. Well done for today. Your challenge now is to go on to Hegarty Maths and do number 61. I will be marking it later and giving out dojos. I think you'll find this one nice and easy. I've tried to start back with something just to rewind, just to get us back into the maths frame of working. And as we go through the week, you're going to use this knowledge, okay? So have a go at the Hegarty Maths. Make sure you understand it. If there's anything you've not understood, dojo me or message me on Google Classroom and I can answer any of your questions. See you tomorrow.